Okay,
That's
so now, why doesn't it just explode as soon as stuff hits the surface?
you need to not just get a little bit of hydrogen onto the surface, because if you put a bit of hydrogen on the surface of a white dwarf, it can just sit there. The hydrogen doesn't feel the need to explode until it reaches a certain density and temperature. And that critical density and temperature mean that in the case of let's talk about a white dwarf star, just for concreteness. That's what most novas are, white dwarf stars. These are guys that are about the mass of the sun, so several 100,000 times the mass of the Earth, but they're only the size of the Earth. And how much hydrogen do they need to accrete in order to become explosive? Well, because they're the size of the Earth, about 8,000 miles across, they need to accrete about a mile of hydrogen, so about a Pacific Ocean's worth of hydrogen onto their surface. At that point, the density and pressure at the bottom of the Pacific Ocean of hydrogen is about 10,000 grams per cc, so about 1,000 times denser than lead. Temperature reaches 40, 50 million degrees. At that point, the hydrogen becomes highly explosive.
Nice.
Boom. You blow up, and you get to be about 100,000 to 1,000,000 times as bright as the sun for a few
I need
weeks.
to clarify something.
Yep.
Hydrogen as a gas
Right.
is explosive. So that's not what you meant.
Right.
Okay, so be precise there.
It is not the kind of explosion that you're thinking of in the Earth's atmosphere where hydrogen combines chemically with oxygen